On this video, we'll mainly talk about how to write the tangent line. However, let's go into the differences between the tangent line and the normal line. On this graph that you see, the black line that you see right here, the black curve, is the regular curve that we have. And the red line is the actual tangent line that we've been talking about in class. So you guys kind of know what it looks like. So it's a tangent line. That red one is representing the tangent line. Okay. The green line is actually the normal line, which means, here's what I mean by the normal line. It means the line that's perpendicular to the tangent line at that point. Perpendicular. Okay. But we call that perpendicular line a normal line. Now, there's a couple things that we need to know in order to write either the tangent line or the normal line. The first thing you need to have is a point. By a point, I mean for you to have x and y points. Because you got to have a specific point for you to write a tangent line at that point. Otherwise, it'll be just a general line, which we really don't do that in Calculus AB. The second thing you have is slope at that point. Now, the regular tangent line slope is that you take the derivative of a function, which gives you the slope of a tangent line at every point, and then you'll plug in a specific point to get the specific slope at that spot. Normal line, which is a perpendicular line, you do that by basically the same thing. You're going to find the regular slope. I'm going to change the verbiage here. So you're going to find the regular slope and make that regular slope perpendicular by flipping it and change the signs as well. And we'll go through the examples so that you'll see what I mean by all of these things. And how do we write the tangent line or the normal line? We write it with a point slope form, which is y minus y1 equals slope times x minus x1. Let's actually practice some of the writing tangent lines first before we do the normal lines. If you read number 8 on the very next page, we're going to write the tangent line as it goes through a point. So for instance, on part A, we're going to write the tangent line of the curve that at point 1, 2. So let's go ahead and see what the curve actually looks like. So our curve looks like this, but we're gonna write a tangent line at that point that you see right here. Okay, so we can imagine what it looks like, but we still have to write a tangent line for that. So let's take a look at it. Okay. First, we need to have a point, which you already have a point, so you don't have to do a lot more work for that one. Sometimes you have to do a lot more work to find a point, but not in this case. Second, we have to find the slope at that point, but in order for us to do that, we have to have the general slope at every point of a tangent line formula, which is given by the derivative. The derivative of this formula itself will be 9x squared minus 4x minus 1. Now that gives us a tool to find the slope of tangent lines at every point. However, we want it at this specific point, so we're going to plug in 1. So if we do, f prime of 1 would be 9 minus 4 minus 1, which gives us, my slope at that point is 4. So we're going to go ahead and write the tangent line for it by using the point slope form. So it'll be y minus y1, which is 2 right here, equal m, which is a slope at that point, times x minus x1, which is just 1. If you want to solve for y by adding 2 on both sides, you can. However, that is unnecessary. But let's go ahead and take a look at what this looks like. So here's where we are. I'm going to go ahead and clear this up. That right there, 4x minus 1 plus 2, remember that's what we had here? or x minus 1 plus 2, okay? That is our tangent line. And let's see if we actually have the slope of 4. Let's take a look, because this goes up by 1. I may not have enough room, so let's take a look. Slope was 4, so it goes up 1, 2, 3, 4, and over 1. So it checks out that we have slope of 4, and that's our tangent line. It crosses there, kind of almost like parallel to that function at that point, and that's our tangent line. Let's try to do another one. How about part C? Once again, they're giving us the point, so all we have to do is find the slope at that point. So let's go and take the derivative of this. But before we do, let's clean this up. Before we take the derivative, let's make this derivatizable. Is that a word? Probably not. So this becomes 8x to the negative 1. Why is it not writing a negative to me? Okay. Wow, that's terrible. Okay. Minus 8x to the negative 2. Now let's take the derivative, which gives us f prime of x equal negative 8 x to the negative 2 plus 16 x to the negative 3. I understand that we have to plug in negative 2, but before we just go ahead and plug it in, let's think to ourselves, are we going to be able to deal with this negative exponents? Probably not. So let's go ahead and bring them down. So this really becomes negative 8 over x squared plus 16 over x cubed. Then let's plug in negative 2 because we know what to do now. So f prime of negative 2 would be negative 8 over positive 4 because that squared is positive, plus 16 over negative 8 because negative cubed is negative 8, which gives us negative 2 minus 2. And our slope at point negative 2, negative 6 is negative 4. That's our slope, but we still haven't written the slope, the tangent line yet, so let's go and write that. So it becomes y minus negative 6 or positive 6 equals m times x minus x1, which is negative 2, so plus 2. So that is my tangent line. That's it.